Hello students, in some earlier videos and lectures, we have seen about the second law of thermodynamics. We had a detailed discussion about the entropy and TS diagrams, and then how all the processes we can plot in the TS diagram. Now we reach at the point where we are going to discuss what is the third law of thermodynamics. In fact, we have already discussed that unknowingly that it is third law of thermodynamics. So if there is some system, we take the heat from that system and it will dump to the surrounding. So as the temperature of the system getting lowered, it is more difficult to absorb the heat from this system. And this is nothing but unattainability statement for third law. So it states that by no finite series of operations is the absolute zero is attainable. So absolute zero means 0 Kelvin. So by any process or any sequence of processes or any series of processes, we cannot achieve the temperature at 0 Kelvin. That's why this is third law is also called as principle of unattainability of absolute zero. There is also alternative statement which is given by Nernst and Simon. So this is called as Nernst-Simon statement. It states the entropy change associated with any isothermal reversible process of a condensed system which is cooled approaches to zero as the temperature approaches absolute zero. This means as we are going to cool the temperature and it is approaching zero, the change in process delta S is also reaches or approaches zero. And we know that it always is positive quantity, it cannot be zero. This means T cannot be 0 Kelvin. It cannot reach up to 0 Kelvin. So this is the alternate statement for the third law of thermodynamics. If we call the entropy at T equal to 0 is equal to S naught and we call it as a 0 point entropy, then alternatively we can also write by no finite series of operations can the entropy of the system be reduced to its 0 point value, that is S naught. So we cannot reach basically up to T equal to 0 Kelvin. So this is the statement for third law of thermodynamics. All the three statements we discussed earlier can be used as a third law of thermodynamics. They are equivalent